delighted to introduce our plenary speaker this morning, Dr. Claudia Kawas. Claudia is a geriatric neurologist and professor of neurobiology and behavior and neurology here at UC Irvine. She serves as associate director of the Institute of Memory Impairments and Neurological Disorders at UCI. Her work focuses on the epidemiology of aging and dementia, and particularly on understanding the predictors of successful aging, a topic highly relevant to all of us in this room. Dr. Kawas has published more than 100 peer-reviewed manuscripts and has worked on many important longitudinal studies of aging, most notably perhaps the 90+ study, which she leads here at UCI. Her seminal work on this understudied population of the oldest old addresses a really critical gap in aging research. Most studies tend to stop in the 80s, if not even younger, and Claudia's work has taught us that really interesting nonlinear changes emerge in that 10th decade of life. Things that are risk factors when we're middle-aged promote longevity once we reach our 80s and 90s. I think my favorite of her many intriguing findings from the 90+ data is that some so-called vices actually turn out to be good for us. So we can all thank Claudia for empirically demonstrating that caffeine and alcohol promote longevity. So let's all be sure to raise a toast to Claudia tonight at the evening reception. Without further ado, please join me in welcoming Dr. Claudia Kawas.
I can't believe you're not out on the beach doing a walk, but welcome to rainy, gray Southern California.
Great. Okay, so many of you may know who this lady is, Madame Jeanne-Louis Calmet. She was born in Arles, France, and sold paintbrushes to Vincent van Gogh when she was a child. In fact, she was on a public television show in her adult life, and she described him as dirty, disgusting, and she didn't think too much of his artwork. But in fact, the story I'm going to tell you mostly about Madame Calmet was when she was 90, because this is a talk about 90-year-olds. So she had a very nice apartment in Paris, and she made a deal with a 47-year-old man that he would pay a monthly fee, and when she died, the apartment would be his. And if he paid 10 years of monthly fees, he would pay the market value for this apartment. And it seemed like a pretty good deal at the time, but many of you probably know that she got not only 10 years, but then he paid for 20 years, and then he paid for 30 years, and then he died. And then his widow paid for several more years, because Jeanne-Louis holds the Guinness World Record for longest lived human. She lived to be more than 122 years old. And initially, when I started becoming interested in the oldest old, I mean, most people's questions was why? And I think one of the shortest answers to that is all of us in this room have a reasonably high likelihood of reaching 100 and beyond. And all of us in this room want to do it particularly with decent memory and learning. And all of us in this room probably are most afraid that that might not be the case. So I thought this was a very interesting quote. You know, more than half of all children born in 2009 in the United States are expected to reach their 103rd birthday. So throughout the world, the majority of the population is going to become a centenarian or even older in the coming decades. And we really didn't know anything about them because, in fact, we specifically exclude these individuals from a lot of our studies of aging. The NINCDS criteria for Alzheimer's disease, for example, that came out in 1984, specifically said we could make the diagnosis of Alzheimer's disease if somebody was between the ages of 45 and 90. And at the time I asked Bob Katzman, who was one of the authors, well, what's wrong with 91? Why can't I say somebody who's 91 has Alzheimer's disease? And it was just one of very, very many times that I realized how really brilliant and insightful he was. But his response then was, well, we just don't know. So when I came to UC Irvine, I kept in mind all these years that we really didn't know anything about 90 or 95 or 100-year-olds. For example, here is age-specific incidence rates for dementia throughout the world. And what you see, let's see if this is a pointer. I don't think it. No. What you see at the left side of the graph is, you know, the risk of dementia at age 65, 70, 75, and 80 is relatively low, certainly under 5% per year. But it's also pretty much the same. It's the same in Germany, which is the purple. It's the same in Brazil, which is down at the bottom of the graph in light blue. But as we get to age 90, you start seeing these rates diverging. And they diverge to the point that some study says the risk of 95-year-olds to have dementia is 30% per year. That's in Munich, in the top purple. And some places say, not only is it not that, but it goes down compared to age 80 and 85. For example, Sao Paulo at the bottom of the graph. And in between, you've got all kinds of estimates, and there's a tenfold difference between the risks suggested by some studies compared to other studies. And unless you really believe that everyone in Munich, Germany should really move to Brazil, what's going on here? So we don't even know the risk of becoming demented at this age, and we don't know what are the risk and protective factors related to longevity or dementia. We don't know the types of dementia people get at this age or how to diagnose them, and so because of that, we started the 90+ study. Now it's 8 in the morning, and I'm very intimidated by this audience who studies much more interesting learning and memory aspects than I do. So I decided, Mike Vyasa actually decided, that I'm going to show you a few minutes of a video clip from, in this case, it's going to be from the 60 Minutes show in the top that they did on the 90+ study, and let Leslie Stahl introduce our investigations, because she actually is more interesting than I am.
We are a nation getting older. By the middle of the century, the number of Americans aged 90 and above is projected to quadruple. Dementia, including that most dreaded form, Alzheimer's disease, is a looming threat and a primary focus of the 90+ study.
I was born on August 25th, 1920, and I'm 93 plus.
1918.
What they have in common is that decades ago, they all lived in a retirement community called Leisure World, 45 miles south of Los Angeles. Today, it's still a retirement community, and they're still getting the most out of life, though it's no longer called Leisure World. It's now its own city, Laguna Woods. Dr. Claudia Kawas spends a lot of time in Laguna Woods these days. She's a neurologist and professor at nearby UC Irvine who discovered the research equivalent of gold here. Information gathered from thousands of Leisure World residents back in 1981, with page after page of data about their diet, exercise, vitamins, and activities. $6 million of funding from the National Institutes of Health, Kawas and her team set out to find out who had died, when they died, and to convince those who were still living and over 90 to sign up.
Now please spell world.
They are given an hour-long battery of cognitive and memory tests.
Good. Now spell world backwards.
DLROW.
They are checked from top to bottom every 6 months.
Big smile?
Their facial muscles, reflexes, balance,
3, 4, 5.
how they walk, how fast they can stand up and sit down, and most importantly, how their minds are working.
You know, unfortunately, there's no blood test, there's no x-ray. It's an examiner finding out that an individual has problems in 2 or more of the main things the brain does for them.
So what was it that got these people into their 90s?
So you've never had a stroke?
No?
While their spouses, friends, and colleagues
Never had hardly anything.
dropped out along the way.
What's your secret?
I wish I knew.
Well, whatever your secrets are, by being in the study, we're going to try to find them out.
Comparing that data to how it's all turned out has yielded a slew of published findings about behaviors associated with living longer.
I really believe that when we learn things from the 90-year-olds, they're going to be helping the 60 and 70-year-olds, not just how to become 90-year-olds, but how to do it with style and as good a function as possible.
So, as you heard, the Leisure World cohort study in 1981 was an investigation by the University of Southern California. And in it, what they did was they sent 18,000 questionnaires to every single person who was living in what was called Leisure World at the time. It's now called Laguna Woods, because they seceded from Leisure World. They didn't like the sloth of the title and the restrictions, and besides they're in California and we're always seceding here. And of these 18,000, 14,000 of them came back, which is also a comment on Laguna Woods. It was a primarily white cohort reflecting the population, both then and now, mostly female, because by age 75, there are 2 women alive for every man. And this was all done during the male, and there were follow-up surveys 4 times over the next 20 years. So the first thing we did was we now know about 14,000 people, about their lifestyle. We know whether or not they were taking vitamin C or E supplements. We know if they were drinking alcohol or overweight. We know if they were self-reporting exercise or leisure activities. And what we wanted to know was, were any of these things associated with living longer? So Karen took a little bit of my thunder, but I will say that I don't know for sure, but I think that I'm not sure if I had told NIA that I wanted to do a study showing that alcohol and caffeine makes you live longer, if they would have been as enthusiastic. So instead I said, I want to show that vitamin C or E, antioxidants, or other things might be associated with living longer. And so we hung a whole lot of our hat, in fact, on the whole antioxidant notion. And in fact, when the dust settles, people who were taking vitamin C or had diets high in vitamin C compared to people of their own age, as many of you probably know. Anyone think this mattered? It didn't. Nor did vitamin A, nor did vitamin E, nor did calcium, nor did soft drinks. No problem, nothing with green tea or black tea. But everything else on the list did matter. And when I'm asked about changing my lifestyle because of things I learned in the study, if the results had been different, I would have had to make a lot of changes. But this made it easier, especially since our body mass index finding was that people in their 80s and 90s who were overweight actually have a reduction in mortality compared to normal weight individuals. And although our study was relatively modest, we showed a 3% reduction, which was identical to what the CDC showed in a much, much, much larger study. So, you know, one of the things I've noticed is Mother Nature, I think, does a better job of taking care of us than we do ourselves. So I think that diet is very important. I just don't think that vitamin C supplements are very important, or vitamin E supplements. And I think that Mother Nature, much to our distress, makes us gain weight as we age. And I think maybe in some ways we should think that this might be a not terrible thing, and maybe even a good thing. I want to qualify some of the things I'm going to say. These things are only true for the people who made it to age 90. But we didn't know, even if you lived long, we didn't know, were you living long but with dementia? And maybe some of these things, even if they didn't make you live longer, maybe they were useful for lowering your risk of dementia or hip fractures or other things that are very important. So I'm not saying these things aren't important, they're just not related to longevity. So what we did is we wanted to see what these people looked like. All of the previous work had been done through mailed surveys and self-report. And so we said, on January 1st, 2003, if you were one of these 14,000 people and you were still alive, And over the age of 90, we wanted to see you. And although these individuals lived in one community, just a few miles from here actually, in 1981, it took 37 states to track down the 1,600 individuals that we ended up enrolling. So the last year or two, we've been taking volunteers who aren't from this Leisure World cohort, but all the data I'm going to show you today is from the first 1,600 that we enrolled, all of whom we had data from 30 or 40 years ago. So here's a snapshot of what they look like at their first visit. You can see now there are 3 women alive for every man, because in every species on the planet where there is a difference in longevity by sex, it is always the female that lives longer. And personally, I think there's a Nobel Prize hiding in that finding for someone to figure it out. It's a relatively highly educated cohort. And in terms of cognition, on their first visit, you can see it was about a third, a third, a third. So a third of them we deemed to have dementia. A third of them we felt were normal, which doesn't mean their performance was identical to a 30-year-old, but and a third of them were in this in-between zone where they had memory or some other kind of cognitive problems, but they didn't meet criteria for dementia. So we ask a lot of these individuals. I mean, truthfully, it's been extraordinary what they've done for us. First of all, we see them every 6 months. And we do all kinds of neuropsychological testing, neurological examination, a lot of the performance measures you saw in the video. We ask them to give us their DNA. We ask them to give us blood samples. We ask them to stick their heads at this point now in 1 MRI and 2 PET scans. And at the end of it all, we ask them if they'll consider giving us their brain, which I think is one of the most valuable things that we've found, and I'm going to show you some of the data from our autopsy today. So, going back to this graph, one of the first things we wanted to know is if you were one of those individuals who did not have dementia the first time we saw you, what was the risk of developing dementia in your 90s? And here's another place that I showed how wrong I am. I actually spent most of my career really believing that the risk of dementia after age 90 probably went down, and you can see some of the numbers here actually suggest that the risk goes down. Some suggest it might level off, and some suggest that it continues to go up. So the bad news is there is no question now in my mind. It not only goes up, it continues a perfect doubling that begins at age 65. So with every 5 years of age, your risk of having dementia doubles after age 65, and that's true after age 90. You can see that from 90 to 94, we're right in the middle of the pack. We had more data than most of these other studies, so we were able to do age-specific risks. So it's about 10% per year in your early 90s. It doubles to 20% per year. And then after age 100, it's a staggering 40% per year. So the risk of dementia is extremely high, unfortunately. And the next thing we wanted to know is that risk of dementia may be related to all of these things I showed you before. And we'll make quick work of that. Dementia was not only not related to any of the things that we had suggested looking at, like antioxidants, but even things that we found to be related in younger individuals didn't appear to be related in older individuals. So we've spent most of my career trying to separate vascular disease from Alzheimer's disease, and now that I'm getting ready to retire, we seem to be trying to put them back together, which is probably the right thing. So the next thing we did was look at vascular risk factors. And you can see that half of the population had hypertension, substantial numbers of people with cardiac disease of various sorts. And when we looked at these in relationship to dementia, it turns out pretty much nothing was related, with the exception of hypertension. Hypertension was protective. Nobody looks like, either you're not awake or that doesn't surprise you. But for most of us, we think hypertension is not a great thing. It is well established that midlife hypertension is a risk factor for late life dementia. And the fact is, though, we're not the first people who have found this. If you study people in their 80s and 90s, you get a finding like we did. So you can see here, actually, here's the data points. So congestive heart failure, stroke, valve disease, diabetes, all the things on the left side of the screen actually now are showing to have an increased risk of dementia when you look at incident dementia. But on the far right, you'll see cholesterol and hypertension, both of which actually, it's not just that they're not a risk factor, they lower the risk of dementia compared to people who never develop hypertension in their life. So it actually appears protective. And I'm not going to go into this in detail in this talk. In fact, I'm not going to talk about it much anymore. But I do want to make one point really, really, really clear. When we dissected this out, this effect is coming exclusively from individuals who developed hypertension in their 80s, mid to late 80s, or 90s. So hypertension, individuals in our study who developed hypertension in their 60s or 70s actually do not have an increased or a decreased risk. Most of these individuals have been treated and their risk is pretty much the same as if they had never had hypertension. But individuals who develop hypertension in their 80s and 90s have about a 25% reduction or more in their risk of having dementia. And this has actually also been shown in several studies now because, as we say in my lab, age matters. So whenever you hear about a risk factor or anything else, if I'm in the room, I'm always asking at what age was that done? Because we've always understood that children are different than adults. At one end of development, we understand that the brain works differently. We understand that the abilities are different, the diseases are different. We have a whole slew of doctors to take care of neonatal or adolescents or pediatrics. But at the other end, we act like we're all bad versions of 60-year-olds. So age matters, and the idea, I thought it was funny, there was this week in the Tuesday's science section for the New York Times, there was an article sort of entitled, Clinical Trials Are Happening, Old Need Not Apply. And it talked in there about how doctors are left to, quote, guess what is appropriate for their 85 and 95-year-old patients because they've not been studied. And then he said the nice word is extrapolate, but the reality is they're just making it up. And I think that optimal care of all of us when we reach this age is really going to depend on more and more studies allowing 80 and 90-year-olds to participate. So what are they being protected from with this hypertension is a real question. Almost every person who gets dementia in this day and age in the United States especially tends to get the diagnosis of Alzheimer's disease, or maybe Alzheimer's and vascular if they've got some kind of vascular history. And yet we haven't really looked at the brains of most of these individuals. So the autopsy study. So 500 of our participants have already enrolled in the autopsy study. We already have more than 300 of their brains. And really, I think some of the most interesting things that we're going to learn, as always, is from this study. My father is a pathologist, and I never really thought what he did was interesting, but now I'm talking about it all the time. So the first thing we did is, if you had dementia, how often did we find significant Alzheimer's pathology that was presumed to be the etiology? And here we got what most people would predict. In the red, 60% of demented individuals who came to autopsy had intermediate or high levels of Alzheimer's pathology that was assumed to be the cause of their dementia, which was very fine until we looked at the non-demented, where 40% of the individuals who were not demented had intermediate or high levels of Alzheimer's pathology in their brain also. In fact, whether or not you had Alzheimer's disease pathology in your brain did not distinguish in any way demented from non-demented. And even when we looked at the few individuals, there's about 50 or 60 individuals in whom we found no abnormalities in their brain except high levels of Alzheimer's pathology. And exactly half of those had dementia and the other half didn't. So the question comes up. You're going to be hearing a great talk from Dr. Risa Sperling, who's going to probably tell you about prevention trials that are ongoing now, including one that she's running called A4. And these studies are, in fact, designed to take the individuals in the left side of the screen, individuals who have no dementia, but appear to have AD pathology in their brain, as measured usually by a PET scan, and see if we can influence the course of their illness, i.e., can we prevent dementia in these individuals by removing amyloid or doing other things. But the question, there's a new concept that's also percolating lately and has become of great interest to all of us. A couple of years ago, the NIA and Molly Wagster at the Cognitive Summit meetings sponsored Resilience Reserve Symposium, where everybody talked about it. And the most common definition of resilience that came out of that meeting in many publications was the individual who does not have dementia but has significant Alzheimer's pathology. So I think we've got the same definition right now for two very different things. When we see this in an individual, does it really mean that they're in the preclinical stages of dementia, or does it mean that they're able to withstand the pathology? And to my mind, at least in one individual person, it can't be both. Maybe it can be both in the group of individuals who fill this criteria, but for a single person, it's either going to be preclinical Alzheimer's, they're on the pathway that many of you have probably seen. How many of you have seen this slide? Oh my God, you go to too many Alzheimer's talks. Yes, this is shown at almost every meeting and every talk, and most of you know it is the put together by cross-sectional data primarily, but it's the notion that Alzheimer's disease is a chronic disease with a long preclinical phase. And the red line on the left is the first thing that sort of starts going up, and that's the amyloid load, followed later on by tau and other problems with the brain and symptoms. And the idea of the A4 study, for example, is that if we study people when they are in the preclinical phase, when they have amyloid and are on the path, that we might be able to make a difference. But it's also possible that people that we're calling preclinical, as I said, are actually really resilient. I really don't know the answer to this, but some of the things that we've noticed in the non-demented individuals in our study who have high levels of amyloid burden is that, first of all, they're more likely to be ApoE2. Almost a third of these individuals, in fact, are ApoE2. Apolipoprotein E, as most of you know, is a genetic susceptibility factor. It's the strongest one we know about. And I think the thing that's interesting, at least in our study, is that the E2s at autopsy have as much Alzheimer's pathology as the E4s. But the only difference is the E4s are almost all demented, and the E2s are almost never demented. So ApoE2 appears to be protective, but not against the amyloid pathology, which was what I assumed was the mechanism. Individuals in that side of the pie diagram who weren't demented but had high amyloid burdens in our study have higher education levels, suggesting some component possibly of resilience or reserve. And whether we've looked at it in terms of autopsy or imaging, these individuals with positive amyloid scans or positive amyloid burdens on autopsy did not have faster rates of cognitive decline compared to individuals who didn't, suggesting the possibility that, in fact, maybe they are resilient, which truthfully I wasn't so sure of as we started this. I'm still not sure of it. In fact, what is going on is going to turn out to be a complex story, but I think a big part of the answer is going to be this. My entire career, I started out, we would all say we were working in aging and dementia, and then after a few years of that, we were all working in Alzheimer's disease, and somehow both aging and all-cause dementia went by the wayside. But all dementia is not Alzheimer's disease, even though sometimes we use the words interchangeably. And so we wanted to see what else is going on in the brains of these individuals. So we looked at Alzheimer's disease, which is up on the left, but we also looked at hippocampal sclerosis, microinfarcts, and white matter disease. Now, the majority of these cannot be diagnosed during life, I want to point out. There is no clinical criteria that has been proposed really or works for identifying an individual who has hippocampal sclerosis. They all get a diagnosis almost universally of Alzheimer's disease. Microinfarcts, as a neurologist, I was taught they're meaningless. They're so little, nobody cares. They're too small to be seen with any kind of imaging and are purely an autopsy finding. And then white matter disease, the difference between white matter disease on imaging and autopsies is light years, but also not good diagnostic criteria. So if we looked at these kinds of things and we compare individuals who had Alzheimer's or compared to those who didn't, or hippocampal sclerosis compared to those who didn't, you'll see in this slide the odds ratios for the different pathologies. So on the left is, the far left is Alzheimer's disease. And if you had high levels of amyloid plaques and tangles compared to people who didn't, you actually had a twofold increase in your risk of having dementia. So it definitely increased your risk. But I want you to notice that it's the lowest increase on the entire slide. Because if you had hippocampal sclerosis, you had an odds ratio of 10, a 10-fold increase in your risk of having dementia. Or leukoencephalopathy, the white matter disease, a 13-fold difference in having dementia. So if I had a choice about what to have in my brain right now, there's no question. Alzheimer's disease is the one to choose. And most people don't think that, but hippocampal sclerosis, virtually universally demented. White matter disease, 3 or more microinfarcts when we looked at just 6 slides to do our count. If we found 3 or more, which by the way probably represents the brain, a total brain burden of 1,500 microinfarcts, microinfarcts was strongly related. There the odds ratio is 4. So 3 or more microinfarcts has twice the risk of having high levels of Alzheimer's pathology. And in fact, although there's a lot of microinfarcts in the brain, really it's only the cortical microinfarcts that are related to cognition. The white matter microinfarcts did not have a relationship to cognitive decline or dementia. Now, most people, however, especially in their 80s and 90s, they don't only get one of these things. So the majority of brains that we look at have several of these things, and the number really matters. If the pathologist essentially said, we didn't find anything in this brain that's particularly serious or related to dementia, there was still a 40% chance of having dementia. If they found one thing, which was most often Alzheimer's disease, it went up to 60%. But if they've got 2 or 3, it's basically 100% of those individuals had dementia. And the number was not only related to the likelihood of dementia, but to the severity. So these are mini-mentals in those respective categories. So if you have 0 or 1, you had mild or moderate dementia, but if you had 2 or 3 or 4, you had a single-digit mini-mental showing very severe levels of dementia. So with all this as a backdrop, what we wanted to know is if one of these prevention trials succeeded, what would be the effect of eliminating or reducing Alzheimer's disease in 90-year-olds, the fastest growing segment of the population? It's going to be 2% of the US population by the time I retire, 6% of the Japanese population, and we constructed the following scenarios. So here, what you see is in deepening shades of salmon, We made the assumption complete elimination is the bottom one, the hot pink one, where everybody who had high, intermediate, or low levels of Alzheimer's pathology were reduced to none. So you wipe every plaque and tangle off the face of 90-year-olds. Substantial reduction would be taking individuals who are higher intermediate to low, and so on. And when we do that, this is what happens today. That is that about half of the cases of dementia in this age group would be taken care of. But what it would do for the future is really what's stunning, because by 2050, we will have more cases of dementia in 90-plus-year-olds than we have at all ages put together in the United States, including 90-year-olds right now. And reducing that from about 4.8 million to about 2.3 million would really have a pretty profound effect on dementia in this age group. But it still leaves the other half. So the attributable risk of Alzheimer's pathology in this age, and I'm starting to think even in younger ages, although we've kind of ignored the issue, because most studies don't look at microinfarcts. Most studies see hippocampal sclerosis and kind of ignore it. But I think that even at younger ages, what really is going on is the idea that the expression of Alzheimer's pathology might be strongly tied to whether or not you're able to avoid these other problems. Microinfarcts, hippocampal sclerosis, and probably some disease X's in there, things that we don't recognize yet. So, I'm glad to say we are in the home stretch. And in summary, there is and will continue to be a remarkable increase in longevity. We've extended life expectancy by 28 years in the last century. And I used to say that's not going to happen anymore and we're not going to continue, but now I actually feel quite differently. Even in the last few years, we have continued to increase life expectancy. I know you've seen some things about how in the United States for the last 2 years in a row, actually, there was for the first time not an increase. But in fact, if you take out opioid deaths and male suicides, those are the two things that are driving those numbers. Because for the individual who's an 80 and not on opioids, life expectancy is still going up. The risk of dementia is really, really high. Age is the strongest risk factor, and that's true after age 90. And it's most likely due to not just Alzheimer's disease, but a lot of other pathologies, some of which we don't even recognize yet. So many of these individuals, however, even with these astonishing rates of dementia, remain resilient, apparently, even in the presence of neuropathology. So we have individuals in our study who are still performing at levels that were probably quite similar to what they were doing when they were 60, and continuing to work. And we signed up a Nobel laureate, actually, for our study just last month. So risk and protective factors and preventions and all sorts of things for all sorts of pathologies really need to have our focus over the coming years, because even if we wipe out Alzheimer's disease, we still have other ways in which we need to protect our brain as we age. Because old people aren't just bad versions of middle-aged or younger elderly, and they have a lot to teach us. So the most thanks I need to give are for you coming here at 8 in the morning, for the participants and their families who let us poke and prod them and do all sorts of things and give us their brains, and the amazing staff and my colleagues at UCI and actually throughout a lot of the United States who are doing studies with us. And thank you.